Hello, and welcome to our webinar. Thanks for bearing with us as we worked through some technical difficulties on our end. Today, we're going to hone in on soybeans, and we'll take a look at the future and where we are today, hosted by Germination. My name is Julie Deering. I'm the editor of Germination and will be serving as your moderator for today. First, I'd like to start by thanking our sponsors who helped to make this possible: Bayer Crop Science, Cantera Seeds, Can, and Syngenta. A quick few housekeeping items to note. This webinar is being recorded and will be made available on germination.ca following the event. For audio quality purposes, all microphones have been muted with the exception of speakers. If you have a question or comment, please share them in the chat box and I'll make note of them. Here's a quick lineup of what's in store for today. First, Shawn Brennamen will talk about soybean production in Canada, one of the crop's biggest threats, and what Syngenta is doing to help farmers tackle soybean pests and improve yields. Second, Meadowsmith of Consortia will share his team's new research and development efforts and how their approach differs from the traditional. Next, we'll have a small roundtable discussion looking at the future of seed treatments with a special focus on biologicals. And then finally, we'll open it up for a 10-minute Q&A session. So with that, we'll dive on in. Our first speaker is Shawn Brennamen, who serves as Syngenta's Agronomic Services Manager for Eastern Canada. In this role, he works to ensure that Syngenta products and solutions meet the needs and provide exceptional value for Canadian farmers. Shawn has been with Syngenta for 7 years. Prior to joining Syngenta, he spent 10 years working in ag retail, where he consulted in seed, crop protection, fertility, and agronomy. Shawn is a member of the Certified Crop Advisor program and currently serves on the CCA Board and Marketing Committee. Shawn, it's all yours.
Thank you very much, Julie. It's my pleasure to talk with you today about, to me, the most devastating pest and yield robber in soybeans in North America, and that's soybean cyst nematode, or SCN for short. We're also going to talk a little bit about a new tool that Syngenta's developed and is offering to help combat this pest, and that tool is called Evapian. Soybean cyst nematode was first discovered in the US in 1954 in North Carolina, and as you can see, over the years since the initial discovery of this pest, it's spread to every major growing region in the US. SCN is a small plant parasitic nematode. It's a microscopic roundworm that moves any way in which the soil's moved, whether it's wind, rain, animals, equipment. Whatever's moving the soil will help move SCN, and that's one of the main reasons why we've seen it spread so prolific over the last number of years. A little closer to home, it was first identified in Ontario in 1988, and here we can see the last major survey done in 2011, and that continued spread of the pest. As equipment's moved from field to field, as soil continues to move, whether it be wind, erosion, etc., we're continuing to see this pest pop up in areas where it wasn't previously identified. For other parts of Canada, it was just recently identified and confirmed in Quebec last year, but I'm happy to report that there's no yet confirmation in Western Canada. So why is this pest important to you? When you look at the damage that SCN is estimated to be responsible for, and you look at the yield that it's costing North American growers every year, when you add up the entire damage from all the other top 10 soybean pests, that damage doesn't yet combine to equal the amount of loss we're seeing from soybean cyst nematode. It is a $1 billion pest. And under severe infestations, combined with additional environmental stresses, yield losses can range up to 100%. But it's often more known as the silent yield robber or yield nibbler, because in many cases, SCN causes yield loss with no visual symptoms, or it's often misdiagnosed in the field as other production issues such as nutrient deficiencies, herbicide injury, compaction, or just plain weather. So oftentimes it's misdiagnosed without understanding that the real root issue is SCN. To fully understand how we can combat this pest, we first need to really understand how it works. And there really are 3 distinct phases to the SCN life cycle. In that top left picture here, you should see a cyst, which is basically the survival sac filled with eggs of the pest. So that cyst protects the eggs from harsh environments and can persist in the soil for many years in a dormant state. Each of those cysts can have well over 200 eggs, and it's from that cyst, as those eggs come out, that the infective stage of SCN, the juveniles, are hatched. The juveniles are hatched from the eggs, and then from there, it's the juveniles themselves that will penetrate the soybean root and will eventually either become a male, which would then leave the root after a few days of feeding, or becomes a female, which stays in the root, swells larger and larger as it matures, and will basically continue that life cycle further on. So the female stays and the male juvenile will leave. The plant damage is primarily due to the feeding of the females, which will disrupt both nutrients and water uptake in the plant. It will restrict root growth and cause indirect effects such as secondary pathogens entry, such as Phytophthora, Pythium, Rhizoctonia, and Fusarium species, which the one we're main concerned about there is sudden death syndrome, or SDS. So those are all secondary pathogens that will be able to enter that root and cause both stand establishment issues and yield loss because of the SCN allowing it to enter in. SCN in your fields, the current management practices include rotation, and it's basically rotation to non-host crops. But it's important to understand that SCN can also infect other crops, including edible beans, clovers, trefoils, vetches, and peas. Another important thing to realize is that weed control is very important. SCN can also feed on certain weeds like chickweed, purslane, vetch, wild mustard, and shepherd's purse. To date, the native genetic resistance has really been the main tool to how we combat SCN. And several different genes, or they call, have been identified in the soil. But even though a variety is labeled as resistant, up to 10% feeding can still occur. Varieties which are labeled as moderately resistant can still have up to 30% feeding on those plants. And of all the resistant plant introductions that we found, one in particular called PI 88788 is used most frequently in the industry and is found in over 90% of the commercially available resistant varieties in the market today. So that we definitely are relying on one source of resistance more than any others. And the issue with this is that we're starting to see a breakdown in the control of the PI 8878, and products, varieties which were previously starting to show greater than 10% feeding, which means that resistance is starting to break down. You're actually starting to see a shift in the virulence of some of the races of SCN in the soil. As well as we've been only selecting for PI 88788, we also start to see shifts of other SCN types, which PI 88788 does not control. So with that, understanding that these shifts are occurring and understanding that we'll be facing with SCN called Chloriva PN. The PN in Chloriva PN stands for Physteria nishiwaki, which is a naturally occurring bacteriospore that has activity on SCN. And how it works is your seed has Chloriva PN applied to it, and as that root begins to grow, the spores are in the soil solution around the root. When that juvenile nematode comes into contact with the spore, it attaches to it, it infects that juvenile, which causes more bacterial production within the juvenile, causing the juvenile to die and to release more spores. So the Physteria nishiwaki is into the soil and can further deter more of the pest. One of the main benefits of this product as well is that it offers season-long protection. It's not race specific, so it will attack all of the soybean cyst nematode races that are currently in the soils. And that's very important because the genetic resistance, as we mentioned earlier, as it's starting to break down or as it's selecting for certain races, this is a product that can offer protection against all races which are present. Also compatible with rhizobia bacteria for nodulation, or with any seed treatments out there such as Cruiser Max Vibrance or Vibrance Max. Here's some of the research trials that we've seen in the last number of years in Ontario specifically. So 6 field scale trials within Ontario, and we see an average of 5.5, where we compare seed treated with Chlorella PN. These are resistant varieties treated with Chlorella PN versus the same variety not treated with Chlorella PN. And these are typically in moderate to high SCN soils. So we've already identified that these soils have an issue with SCN. The 5.5% yield increase. In the US, they've had the product a little bit longer, and so we're looking at 68 different field trials there in the same environments, moderate to high SCN environments. And over multiple years, they're seeing a 4.1% yield increase of using Chlorella PN versus not using this seed treatment. And here's a picture from Ontario where we're really, by reducing the damage of SCN, we systems able to better utilize the water nutrients available and setting up for better yield. So just to recap, Chlorella PN offers season-long protection. As well, it's a part of the tool set that we have available to really look at combating SCN and the management practices available with it. It helps to enhance the performance of resistant varieties, which are currently on the market, and really is to just help to be able to take down this billion-dollar pest so we can get more yield and grow more. And that's the end of my presentation. I'll hand it back to you, Julie.
Thank you, Shawn. Let me see here. Okay. Our second speaker for today is Marcus Meadows-Smith of Consortia, the biological products for seed treatment research and development company. Marcus joined Consortia in February of 2014 as a chief executive officer. In joining a newly formed company, he has been tasked with leading Consortia through the business development and commercialization phase for its groundbreaking advanced microbial selection products. Prior to joining Consortia, Marcus served as CEO for AgriQuest, a $10 million financially distressed biopesticides company, which he turned around in just 4 years and sold to Bayer Crop Science for nearly $500 million in 2012. This started an explosion of big ag chemical company acquisitions of biological product producers and heavy investments in the biological products category. Marcus also spent 14 years at Chemtura, where he was executive vice president and responsible for $2 billion in crop protection, consumer products, and plastic additives businesses. And with that, I'll turn it over to Marcus.
Thank you, Julie. Hopefully everyone can see my screen now. Sorry for that slight delay. So yes, just wanting to pull up on my background, wanted to make it clear that the first part of my career was on the chemistry side of the industry with Sumitomo and then with Chemtura. And back when I was at Chemtura and Uniroyal, they were the leaders in the seed treatment industry. It was only in 2008 that I moved over to the biologicals space with AgriQuest, but very much focused on identifying how we could make biologicals and chemistry work well together in order to make high production agriculture even higher performing, such that culminated in the acquisition of AgriQuest by Bayer Crop Science when I became head of biologics for the Bayer Group. Within the Bayer portfolio is obviously Poncho Votivo, which is, I believe, the best-selling seed treatment in the US for corn and for soybeans. That was originally Poncho, a chemistry. Bayer made a combination product of Poncho plus Votivo, so a chemistry plus a biological, which expanded the spectrum to include nematodes and also expand the spectrum of insects that were controlled, and therefore were able to expand the market of that product. After a brief retirement, I joined Consortia, and I did that because it's another very exciting and very different play in the microbial space, which I believe is the future of many areas of crop protection and increasing yield performance in crop plants in general. The company is actually about 20 years old. It had started off as a contract research company working for companies such as Syngenta and Monsanto, amongst others. And for the first 15 years, went through the standard model and became experts in microbiology and high throughput screening of microbes and natural product chemistry and genes from those microbes to go into GM crops. But around 2009, the company made a breakthrough discovery of the advanced, what we call the advanced microbial selection process, and since then has been funded by US private equity companies in order to develop and exploit this breakthrough discovery. The discovery sort of has many of its fundamentals and learnings from the human pharmaceutical industry, where there has been an explosion of research going on that has been enabled by the low cost of DNA sequencing. So instead of just looking at individual microbes, we're able to use DNA sequencing and fingerprinting to understand whole microbiome. So we can look at the human gut and see what is positive and what is negative in there. So rather than focus on diseases, we now have a whole language around probiotics for humans. And this is also something that can be developed in the plant world. So first part of my career at Sumitomo and Uniroyal was all about plant pathogens. How did we produce pesticides in order to control diseases? What we're able to do now is look at how do we identify beneficial microbes that actually aid the plant in multiple ways. That could be biopesticides, but it can also be making macro and micronutrients available. It can also be sending hormones and chemical triggers to the plant, telling it to grow in a different way, grow larger or change the root structure, not just in size, but in shape and form as well. So it's a really exciting area that has developed thanks to learnings from other industries. We focus on producing microbial products. They are actually multi-microbes. They are fermented as single microbes, but then blended at the point of formulation. And for row crops, for soybeans specifically, we're looking at seed treatments as well as in-furrow application. So this is the ability to throw microbes into the furrow at planting time. So the microbes will go down the furrow and also land on that seed. So it's almost a real-time seed treatment. There have been a lot of companies moving into this space. So we've mentioned Bayer acquiring AgriQuest, BASF bought Becker Underwood, Monsanto has come in a very big way with its deals with Novozymes, an acquisition of Agratis. DuPont has made a small acquisition with Taxon. So it is an area where a lot of people have moved in. What's different about our company is that we use directed selection to develop microbial teams that improve plant traits. Very different from the conventional model, which is one where you isolate microbes from the environment and then test them one by one to see if they have an impact on the plant. We are actually looking at whole microbiome or whole communities of microbes at one time in order to, first of all, use directed selection to evolve that microbiome, and then to identify the small group of microbes that are positively impacting the plant trait of interest. This slide really on the left-hand side is simply saying that every soil is different. It has a different microbial community. So we've all been aware that, you know, we have clay soils, sandy soils, loams, different pH soils. But in addition to that, the microbial community within each soil is different. So along the x-axis is the different species of microbes there. On the y-axis, or the height of the peak, says how abundant it is. And if you have a pathogen in the soil, one of those peaks would be that pathogen in the soil. Luckily for the grower, nature has made our job slightly easier in as much as when you plant a seed in the soil, the moment it germinates, it starts to produce an exudate that feeds microbes in the soil. And so rather than the microbiome of the plant or the microbes that associate with the root system and those that are endophytes that grow through the plant tissue being a reflection of the soil, the plant is actually able to accumulate the microbes that are useful to it. And so you can see on the right-hand side that the corn that was planted in soil 2 actually has a very different profile than the soil it was grown in. And it attracts and accumulates the microbes that are useful to it. But sometimes, unfortunately, it also is seen as a food source to pathogenic microbes, and they can also be attracted to the plant and attack it. So our research model that is proprietary and patent applied for is one of directed selection. So we operate not so much like microbiologists, but much more like plant breeders. So we will plant 1,000 seeds in soils and grow them in growth chambers where we keep constant light, constant fertilizer, water regime. So all those plants should be as near identical as possible. But what we actually find is a normal distribution. And on the left-hand side, in the worst cases, you will see death because it attracts pathogens. Some of those pathogens will just rob yield or reduce the phenotype that you're looking at. The vast majority of them will do what Monsanto or DuPont Pioneer say on the bag of seed, and they will give an average phenotype. But some seeds are actually very lucky, and they accumulate and attract the right set of microbes that give them a superior phenotype. So we use an iterative process. We grow seeds repeatedly, we move the microbes forward, and we are therefore able to evolve the microbiome and therefore shift the normal distribution curve off to the right. We can do this either in the absence of a stress, or we can do this with a stress such as an abiotic stress, drought, cold and wet start, nematode infections in the soil, and at each round we will identify the best performing plants for whatever phenotype it is that we're looking for, and therefore select the correct microbiome that is able to, when those microbes are added as a seed treatment to the seed, are able to improve the phenotype of that plant. So here's an overview of the process, and the first step is actually to create genetic diversity. So the same way as a corn breeder will go back to native corn in order to create his genetic diversity, we take a diverse range of soils, and we will go to good agricultural soils. But if we're looking for something like drought resistance, we might go to deserts and arid lands. If we're looking for nematode resistance, we might go to fields that are known to have a nematode problem and collect soils from those areas. We then go through a process of inoculation, allowing those plants to accumulate on the selection process. And only at the final step of the best performing plants in the presence of that selective pressure, we then isolate the microbes. And as you can see along the bottom of there, we are actually using DNA sequencing and microbiome analysis to inform our decision process. What microbes are present on the high performing plants versus the low performing plants, and making sure that we isolate them at that final step. Off a single high-performing plant, you actually get, somewhere between 100 and 300 different microbial species. But for sake of example, I've taken 5 here, A, B, C, D, E, 5 different microbial strains. And what we do is we go through a process of elimination to identify which of the microbes that are necessary out of the 200 or 300 microbes that we found that actually positively impact that phenotype. So that could be nematode control, for example. At this step, we are able usually to identify somewhere between 2 and 6 microbes that are having the benefit out of that. But rather than, as I said, rather than look through a freezer full of 60 to 100,000 microbes, which is what most companies have in their collection, we're going through a process of elimination and deduction in order to identify the microbes that are necessary here. So this is actually a very rapid and very low-cost model compared to the conventional microbial and traditional model for identifying microbes. So as we can see in this slide, we're actually able to screen 100,000 different microbial strains and take it through this funnel very rapidly in a time of less than 9 months in order to have prototype products that are ready for field testing. And we're able to do that in 9 months versus the conventional model that would probably take 3 to 4 years with the same number of people working on the project. So a very fast and cost-effective model. The other true advantages of our process are that we are able to identify a team of microbes because they were selected together off a single high-performing plant. We know that they work together, and we identify those that are performing complementary functions. The microbes that we're putting together in that final team often are comprised of endophytes, or those microbes that grow through the plant tissue, the epiphytes that grow on the leaf surface, and the rhizospheric microbes that are growing on the root system and helping the plant in many different ways. So we're looking, as I said, for complementary functions. Because of the way we work the model, we have pre-selected for good plant colonizers, because that's where we selected them from, off that plant. We know that the microbes that over history have evolved to kill one another because they usually compete for space, we've actually isolated them off a single plant, so we know that they are able to live together on that plant, either because they like one another or because they colonize different parts of the plant. Our whole model is about improving best agronomic practice that is out there today. So we actually work with best hybrids in the industry with best available seed treatments already on the seed. So we're also pre-selecting for microbes that are compatible with modern seed treatment chemistry, such as fungicides and insecticides that you would find on your seed. And we're looking for an improvement over and above that. The next slide shows where we are. We are a young R&D company, so we are at the stage of field trials for looking at microbes that improve on standard agronomic practice in the absence of any stress. We also have microbes for nitrogen use efficiency. So these are out there. What we're looking to do here is allow a grower to reduce his fertilizer input and still hold the same amount of yield, or keep his current fertilizer regime and increase yields. We're looking at other nutrient efficiencies, but they're at the level of proof of concept. Drought tolerance are already in field trials this year. We have nematode control that is currently at a growth chamber evaluation stage. So we have a number of microbial leads, then they're now moving through our pipeline. So that's where we are as a company. So growers won't be seeing our products in the US until 2017, but we are making rapid progress now with this whole revolutionary area of teams of complementary microbes identified through a very revolutionary research model. Some of the trials results that we've seen so far are highlighted on this slide. In addition, one that isn't on here is for nodulation on soybeans, where we've selected for nodules. We actually had over 100% increase in nodule size. We are with soybeans. I know that's what you phoned into or to listen to. We haven't had field trials results to date. We have products under trial this year and look forward to talking to people in future about how those trials went and how we were able to improve the performance in soybean crops. What we did show last year in our first year of field trials in the US that also reflected what we had previously seen in field trials in New Zealand was that we were able to get a good yield increase on corn and on wheat. And I think what was very important was the consistency of our products, where we were on our best performing product showing a 90% consistency, which is very different from what people have seen historically with microbial products that have been launched, where people have usually talked about a 50 to 60% consistency rate where they could see a benefit. So those are the things that we are expecting to bring forward with the next generation of microbial products. And with that, I say thank you very much for listening, and I will now try to get you back to Julie.
Great, thank you, Marcus. It's clear that you've been busy, and this is certainly a sector of the industry that's making a lot of headway, and we have seen a lot of investment in this area. And that brings us to our next segment, the future of seed treatments. Here's where we'll switch to more of a roundtable discussion with our speakers, both Shawn and Marcus. Can you both hear me?
Yes.
Yes, can you hear me, Julie?
Yes. Okay, great. Well, I'll direct this question first to you, Shawn. Where are we today with seed treatment technology and biologicals?
So I think we're on the forefront of a lot of exciting things and developments. Really, biologicals have been the main talking point from a lot of companies in the last number of years, and Syngenta is no different. That as a crop protection company and seed and trait genetic company, we see biologicals as a very key, important part of that future solution integrated portfolio, just to be able to look at bringing forward the best solutions we can to help growers. So I think we're on the forefront of it. I think the main thing when we're talking about seed technology is really about understanding this changing landscape we're in today, and specifically, talking about Ontario and the number of interactions with NGOs and the government and the public understanding of the agriculture sector, I think we'll see a lot more of that in the future as well, to better understand the benefits of seed treatments, hopefully, and be able to help growers get the best stand establishment and best yield they can.
Great, thanks, Shawn. And Marcus, you have been working with biologicals for quite some time now, or in this sector of the industry, and have really seen it evolve. From your perspective, how have things come along in the past 5 years, and where are we headed in the future, and what are some of those industry trends? Okay,
so today the biopesticide market is about just slightly over $2 billion. The biostimulant market, which is those biological products that aren't making a pesticidal claim but helping increase yields, is about $1 billion. Both of those markets are reported to be growing at and projected to continue to grow at 10 to 15% per annum. But I think there's actually going to be a step change as the big companies now start to launch their products. So as we mentioned, your BASF bought Becker Underwood for $1 billion. Bayer bought AgriQuest for $500 million. Monsanto spent $300 million on their deal with Novozymes. So these are very big players now involved in the space. Monsanto this year is reportedly testing 2,000 microbes across 70 locations. So we're going to be bringing forward a new wave of products that are delivering a superior performance and a higher level of consistency. And I think we've already seen a step change, and I think the numbers of that 10 to 15% growth are actually masking some very, very rapid growth in the seed treatment sector. As I mentioned, Poncho Votivo from Bayer, highly successful, possibly the best-selling product for corn and soybeans in the US. So it is a very exciting space. I think, besides the DNA sequencing and the microbiome analysis that I talked about, I think there's also a lot of learnings coming over from the food industry, the fermentation industry, and the pharmaceutical industry. So I think companies like DuPont and Monsanto's link up with Novozymes, so those people who have pharmaceutical fermentation capabilities with a very strong agricultural background are going to be bringing some very exciting products forward in the next 2 or 3 years.
Great, thanks, Marcus. This next question I'll ask of both of you, and Shawn, if you want to kick it off. It's clear that the science is advancing rapidly in this area, with the investments that the larger companies have made here and some of the products that we're starting to see hit the marketplace. How are you staying up to speed on the science and trying to stay ahead of the curve there?
Yeah, thanks, Julie. To me, at the heart of it, Syngenta is a solutions-based company, and we definitely try to make sure that we not only understand the current challenges and issues that growers are having out there in growing the best crop they can, but then what are some of those things that, as we're dealing with living systems and this changing environment, how do we stay ahead of any shifts in whether it's pest pressures, resistance, new pests which are coming out in the marketplace. So it's really having that on the farm, in the field, with the grower, hand in hand, understanding the current challenges, but then trying to have that forward look to say, here are some emerging pests that we see, given the environment, are going to be an issue going forward. And I'm thinking of two in particular that we see now. Japanese beetle, for example, in soybeans is definitely a pest that I'm concerned about. It's been introduced here in North America and really doesn't have any natural predators. So that's just one example of a new pest, an emerging pest. And then we think about Western bean cutworm in corn, and how any of the BT traits really took care of corn borer, but allowed this other pest to kind of start to flourish. So there's examples out there where, as we deal with these systems, we just have to make sure that we understand fully what the long-term impacts are and how these shifts and environmental changes occur.
Thank you. It's certainly imperative that we stay on top of the science and technology and try to get out in front of some of these pressures. Shawn, from your perspective, in bringing new products to the marketplace, such as Evapian, what challenges need to be addressed as companies move these things through the research and development phases?
Yeah, great question. To me, it's all about the value that the products that we're bringing forward provide our customers, and that's an important part of my role, is to say, what is the actual value? What's the dollars per acre, bushels? What's the quality improvement, standability? At the end of the day, how do our products and solutions help a customer grow a better crop? And whether that's make more money or improve quality or storability, whatever that is, it's how do our products do that? So really understanding that value, to me, is very important. I think that's where we have a great advantage in Canada with the PMRA that's out there, that it's pretty tough to launch or bring a product forward if it doesn't provide value. Whereas the U.S. system is a little different, and you can have quite a few players in a market that, in some cases, don't have to substantiate their claims on product performance. Whereas in Canada, we're very fortunate that way.
Okay, great. And Marcus, from your perspective, and your team is a little bit different in its business model and structure, what are some of the challenges that your team is very conscientious of or aware of as you look to move products through your R&D phase, and what criteria must they meet before you deliver them to a customer?
Okay, so our model is to take our products through to partners. So we are an R&D company. We have about 34 people split between New Zealand and the United States, 12 of them PhDs. So we're all about the science. And beyond that, we have a community of universities and specialists that we work with to help bring forward products that are superior in nature, bring higher yields and more consistent performance. We don't have a route to market if we're not able to deliver a superior product, because all of the large companies now have their own in-house solutions that we wouldn't make progress if we weren't able to deliver something that was better. But as a small company, we have to remain very focused. So we're focused on using our AMS process to identify these products, but we're focused by crops. We work on corn, soybean, and wheat primarily, and then we're going after some of the big issues that grower have. So fertilizer use efficiency. So fertilizer is one of the most expensive input costs. We have environmental issues now with nitrates ending up leaching down into groundwaters, running off into streams and rivers. So helping the grower improve his fertilizer use efficiency will give him a cost saving and an environmental benefit. We're seeing more climate volatility, so we're working on drought as well as helping plants overcome cold and wet conditions that they will find in the spring. And then on the disease front, we're working on soybean nematicides and on corn rootworm products. So, when you're small, you have to remain very focused. All of our spend is on the R&D. We don't have a sales and marketing team, but we look to partner. So it is all about the science and bringing forward great solutions for growers that are going to help them be more profitable and be higher yielding.
Great, thanks, Marcus. Shawn, this next question is for you. What can farmers and retailers expect to see with regards to biological seed treatments in the next 5 years?
So specifically from Syngenta, we will see a whole lineup of Clariva brands, and what will happen and change will be the Clariva will be the main brand name, but then those last two letters will change. So PN for now is our SCN solution with the Physteria nishiwaki in there. But as we go forward, there are multiple nematodes which definitely hurt the yield and establishment of multiple crops out there, whether it's root knot, root lesion, stem bulb nematodes. And so as we go forward, we'll continue to launch Clariva products, which are very specific to targeting those particular nematodes, which are causing economic loss to growers. As well, we're working on some very early stages of some biostimulants. And I think also we'll start to see more of the application, both the technology and the accuracy of applying products continue to improve in the near term here.
Great, thanks, Shawn. And Marcus, taking a slightly broader view and approach to what retailers can expect, you know, kind of if you can peer through your crystal ball, so to speak. What do you think farmers and retailers can expect to see from the industry as a whole as they progress this science and bring new products to the marketplace?
Yeah, I think in the sort of the 5-year time, you're going to see this next wave, as I said, of the products that we're working on: fertilizer use efficiency, helping plants tolerate abiotic stresses, and then some very specific targeted biopesticide effects. But I think as we look into the future, I think with microbiome analysis, understanding how synthetic fertilizers and pesticide applications to fields have somewhat changed the microbiome of those fields, I think as we look at the whole microbiome, we might be finding ways to actually improve the whole community. So I think the first wave is going to be specific solutions, microbes added for a specific biopesticide effect, or a microbe added to overcome an abiotic problem. And a lot of those abiotic things, they are substitutes for or they're complementary to traditional plant breeding or genetically modified crops. I think at some point we will be able to attack things like the problems associated with repeat cropping, which is likely to be a microbial issue. We're likely to be able to help restore some of the qualities of the soils that may have lost by intensive farming. Because what we have to do as an industry is actually make intensive farming more intensive, i.e. we have to increase the yields per acre and continue to drive that higher. But we have to do that in a way that's sustainable and environmentally sensitive. And I think that's where we will get to as the understanding increases.
Thank you, Marcus. There's certainly a lot of work to be done on this front, and I know farmers are excited about some of the things that are coming down the pipeline. At that point, this does it for our roundtable discussion. So we'll go ahead and move into our Q&A session. And as I stated at the beginning, please type any questions that you have into the chat box, and we'll make sure our speakers have an opportunity to answer them. I see that some of you have already done that, but if you haven't and you have questions, please go ahead and put them there, and we'll make sure they get addressed. So a couple of the questions that were typed in early on, and Shawn, I believe these are directed towards you. Can you speak to what Clariva is compatible with that's currently on the market? There was one that was referencing Stress Shield from Bayer, and another regarding fungicidal seed treatments for soybeans.
Yeah, absolutely, Julie. So currently, we've done the analysis and the testing, and Clariva PN will be compatible with the majority of the, I'd say, the market leaders for any of the bacterial rhizobia. So any of the products out there should be no issues. It's very stable on the seed, and ultimately it will be compatible with fungicides or fungicide and insecticide combinations, such as Vibrance Max or Cruiser Max Vibrance beans.
And how many days in advance can Clariva be applied, or Clariva PN be applied before it's planted?
It has a very long shelf life and could be applied the fall before the planting season. So if you wanted to treat your beans and put them in storage in October, November, there'd be no issue treating them with Clariva PN and storing them until the next planting season.
So we're looking at a much longer shelf life there.
Compared to standard rhizobia, yes.
Okay. And is Clariva PN as a seed treatment for soybeans, will that be available during the 2016 planting season?
Yes, absolutely. It will be available from major seed companies and from commercial treaters for the 2016 season.
Great. Okay, and then this next question is for Marcus. Marcus, has Consortia biological products been growth chamber or field tested on soybeans? So there are two parts to this, maybe three. Can you discuss what these tests have demonstrated? And are you interested in conducting future tests and partnering with different seed treatment and or ag chemical companies?
Okay, thank you. So yes, we've done extensive work in growth chambers under stress conditions and under standard agronomic conditions, as I said, trying to involve that microbiome and then identifying the microbes that can help the soybean with early vigor. We've looked at root nodules that help the plant with nitrogen fixation and help with its growth. So we have a lot of very positive data from the growth chamber, so much so that we are now out at in field trials this year, 20 locations in the United States, and we'll be able to report on the results later this year. If our ability to move from growth chamber to field trials with corn and show the positive effect is anything to go by, then we expect very good results at the end of this year. Yes, our model is one of partnership. We are already in discussions, and we have a number of trials already out with partners in the US. Unfortunately, they're covered by confidentiality agreements, so I can't say any more than we have agreements in place. But our model is one to engage with the large seeds companies, agrochemical companies, and fertilizer companies. So we're working at improving a whole range of plant traits, including fertilizer use efficiency. So we have seen significant interest from fertilizer companies, people who you wouldn't normally have expected to go into the biological space are showing an interest.
Great, thanks, Marcus. Shawn, this next question is for you. With the increasing scrutiny over the use of seed treatments, especially neonicotinoid-treated seed, is Syngenta spending more resources in the area of biologicals and or other natural resources in looking to control pests and enhance plant growth, and how so?
Yeah, great question, Julie. So I wouldn't say as an R&D group globally that we're spending more money. I think this is something when you look at a product like Clariva that's been brought to market and available for next year, it takes several years to go through the R&D process and to be able to make sure that you've got a product which provides great value to your customers out there. So this has been in the works for quite a long time. And I think it's back to that point that we look at what the current issues agronomically, what are frustrating growers today, but then also try to take a look into that crystal ball to say, where do we see issues going in the next 5-10 years out? And I think this is a prime example that, we understood a while ago that SCN was starting to shift, that the resistance that's built into varieties was starting to change, and that the current solutions on the market just were not going to provide the level of satisfaction that growers were looking for as far as yield. So to me, it's not that we're spending more money on biologicals. It's probably more that we see wherever a solution can come, whether it's a seed treatment, whether it's a part of a trait, whether it's part of the natural genetic ability of a plant, we really look at more of that integrated solution, and that there's no one solution for any type of issue out there, that the more you can use all the tools accessible to you, whether it's rotation, management practices, tillage, et cetera, the more successful you're going to be. And so it's just, how do our products and solutions combine with all the other tools out there to bring forward the best solution for a grower?
Thanks, Shawn. And in talking with farmers, what do you think is the most important thing to explain to them today explain to them regarding today's biologicals versus that of 10 and even 5 years ago? Because, sometimes farmers think biological products are more like snake oil, so to speak. And so how do we tell them that they're different today than they were, several years ago?
Yeah, I think back to the Canadian environment, that I feel that we're very fortunate that a lot of times products don't come to market in Canada unless you can prove the efficacy and the value to the farmers. So I think we're in a little different landscape versus some other countries out there. But ultimately, it's as the science continues to change and evolve, people get more efficient, more effective in bringing forward the products and solutions. And I think at the end of the day, it's the grower that side by side in the field or trying it in a problem field will make the ultimate decision at whether or not the technology solution or the entire systems approach is worthwhile to them and bringing them more yield and better production.
Yeah, Julie, maybe I can add to that, because I was sort of at AgriQuest when I first got there. I think, snake oil was an accusation that was leveled at the whole industry back in 2008. And I think what has shifted is the efficacy, the consistency, and the cost and the additional benefits that biologicals can change, together with the fact that now the big companies are taking them to market, having done a lot more work on the formulations, on the research to understand exactly how they work and where they should fit in the spray program. So I would say today, when you look at the range that I'm most familiar with, which is Bayer's range of products, you would say people are using them because they are best practice. So I think Serenade is used in a spray program on fruit and veg because it is an exceptionally good fungicide, and used in rotation with other fungicides, it will help control diseases as effectively as a chemistry, and will help manage resistance and manage pesticide residues on those crops. Today in the US, growers are using Poncho Votivo on corn and on soybeans because it's the best seed treatment on the market in the US today. And so I think there has been a shift now, is that as the large companies bring them forward as part of their portfolios, I don't think people will be thinking, biologicals versus chemistry. They'll say, what is going to help me increase my yield? What's going to help me use my fertilizers more efficiently? So what seed treatment should I be adding to my crop in order to maximize the yields and maximize the profit off my land?
Thank you, Marcus and Shawn. I think we've hit our 10-minute mark for our Q&A session. and I'm getting the nod to go ahead and wrap things up here. So I just want to take a quick moment and thank our sponsors for making time, or our speakers for making time in their busy schedules to share this information with us. I really appreciate both Shawn and Marcus sharing their expertise and insight, and hopefully you found this information of value. And again, a big thank you to our sponsors, Bayer Crop Science, Cantera Seeds, Can, and Syngenta. And also, this wouldn't have been possible without a terrific team behind the scenes. Thank you to Jill Holosi, our Director of Digital Strategies, Lynn Roy, our Marketing Manager, and Caleb, our Senior Web Designer. Thanks again for joining us. This presentation will be made available online at germination.ca. And again, we hope you have a great day. Thank you.